Hello everyone, welcome to Probability Week, question number 5. This is a tough level question and we are going to go through step-by-step solution of this problem. The solution is derived from the previous problem we did, so if you have not seen it, the link to that problem is in the description and above. As you know, I am a fan of actually solving the problems to get understanding of the concepts. So I'm going to give you a challenge question at the end along with an answer. I hope you will actually follow this approach, understand it, and then use it to solve the challenge question correctly. So stay tuned for the challenge question. In the previous video, we talked about different categories where we distribute n items into r bins. This is category number 2, where you have distinct items but they are being distributed into identical bins. As a result, that when they are distributed, arrangements do not matter. For example, putting all of the items into bin number 1 is same as putting all of them in bin number 5. Since the bins are lookalike, it doesn't matter. Similarly, this 2 to 1 distribution is also exactly same. What you would notice is that the number of the fruits is 2 to 1, but also the type of fruit into each of these bins is same. So orange and banana is in this bucket and orange and banana is in this bucket, and it doesn't matter which bucket they are in because the bucket or the bins are identical. So this is same, we can't count them as 2. However, if it were a different arrangement where this was an orange and apple and this bucket had a pineapple and an apple, then you would think of them as different arrangements. And this creates a little bit of complexity. However, if you solve it step by step, you will see that it is not that big of a deal and we can follow almost the same process that we did in our previous problem. So the way we are going to solve this problem is we are going to look at some of the unfavorable ways, which are the ways where there are no balls in at least one of the buckets, and favorable ways where there are at least one balls in each bucket, and then combine them to find the total ways. And finally, our probability would be favorable ways divided by the total number of ways. So what are our unfavorable ways? Before we get into that, let's look at the question. We have 5 different fruits as we saw, and we have 4 blue buckets of the same shape and size. The same shape and size is the trigger word that brings us to the fact that all the bins are identical and hence the arrangement within them does not matter. And the ask is for us to find what is the probability that each one of them has at least one fruit. And there is only one favorable way and the rest of them get one fruit each. That's the only favorable way. But we'll start with some of the unfavorable ways so that we start getting the understanding of how to calculate the number of ways. Okay, so in the first case, we are going to select 5 fruits from 5 and put it in one bucket, and since the arrangement doesn't matter, we are not really going to do anything with it. So selecting 5 fruits from the 5 given fruits is 5C5, and the rest we can do in just one way. We are not going to rearrange anything. Similarly, here we are going to first select 4 fruits out of 5, and that the rest of the fruit is one fruit, which we can select in 1C1 ways. And again, there is no arrangement here because the bins are the same. So I'm just going to fill it in one way. It doesn't matter where I put the one fruit in the second bin, third bin, or fourth bin, for example. It's the same arrangement. Things start getting a little bit more complicated as we go on. So here we will select 3 fruits out of 5 and we have 2 remaining. However, we can pick up all of those 2 fruits and put it in the next available bucket, and the rest of the buckets can be filled in one way because they'll just get 0 fruits. Again, it does not matter whether the 2 fruits we choose, whether it goes in the second bucket, third bucket, or the fourth bucket, it is exactly the same arrangement. We select 3 fruits and put them in the first bucket. Now, out of the 2 fruits, we can select 1 fruit and put them in the second bucket. We can select 1 fruit out of the remaining in 1C1 ways. However, as you can see, that what we have actually done is counted the number of ways we can select and arrange this 1 and 1, but they are identical. They are being sitting in the identical buckets. So it would look like an apple here and an orange there is actually same as an orange here and an apple here. So it doesn't matter. However, in this method, we have actually counted for the arrangement. So we have to divide it by 2 to discount for the arrangement, and we get 10 ways here. Similarly, For the last combination 2210, we will select 2 balls out of 5 in 5C2 ways, the remaining 2 balls in 3C2 ways, and then it will be one way to distribute the rest of the 1 ball. Again, however, we have double counted this arrangement of 2 and 2, so we'll have to divide by 2, and this will give us 15 different ways. So this gives us a total of 41 unfavorable ways. Now let's look at the favorable ways. We will start the same way. From the 5, we will select 2 fruits multiplied by, from the remaining 3, we can select 3 fruits and just distribute 1 each because the order doesn't matter. So we can do this way, which gives us 10 ways of doing this. We could also do it in a different way. We select 2, then for the next 3, we can select one of them and put it in the second spot. Then from the remaining 2, we can select 1 and put it in the 1 spot. However, when we are doing this selection, we are actually taking care of arrangements because we are trying to find the number of ways of to fill each spot, and as we know the arrangement doesn't matter, so we'll have to divide it by 3 factorial, which will give you the exact same result. So you could use this way or this way. Both ways are absolutely fine, and it is good to know that you could actually use both ways to come to the same conclusion. So finally, your favorable ways is 10, your unfavorable ways is 41. So your total ways would be 41 plus 10 equals 51, and your probability of getting at least 1 would be 10 divided by 51. And as you can see, none of the answer choices actually is the answer. So E, none of the givens, is the correct answer. As promised, here is your challenge practice question to practice the approach you just learned. All I have done is change one detail of the problem. Instead of 4 blue buckets or 4 identical buckets, I have made it to 3. And the answer choices are exactly the same as well. And you can pause here to actually attempt the question yourself. And I will reveal the answer in a second. And the correct answer to this question is B, 50 by 82. Which is actually 25 divided by 41. What you will get is 41 total ways and 25 ways of distributing the fruit so that each bucket get at least 1 fruit. I hope you like this video, and I hope you learned something new that will stay with you. If you like this video, please do not forget to press like and also subscribe to my channel. Thank you so much. Have a good one.